I have a Darrex E90 end mill sharpener, and like a lot of the things that in my shed, I acquired it originally broken and incomplete, and for a very good price, or next to nothing. And I've then gone ahead and repaired it and done all sorts of bits and pieces. The end mill sharpener has an air bearing shaft on it, and that was missing, and so I've tried to recreate it. I used a piece of hollow bar. I'm calling it mystery metal because I don't know what it is. It's a carbon steel of some sort, but exactly what, I don't know. And this is a clip basically showing how I used my lathe, which is getting on in years and has some wear in it, to produce a shaft which is concentric within about 5/10 and accurate in diameter to around about 2/10, something like that. So it worked out quite well. There's some interesting things to learn out of it, as well as a caution first in to be very careful about what you're doing. If you're unsure about something, take it slowly and work your way through it. And if the little voice inside your head says this is looking a bit dicey, stop, listen to the little voice. The first lot of footage I had of this operation made it look deceptively easy, and so I thought I'd better redo that. So this isn't the real piece, but it's actually a piece like it. To clean up the end here for my counterbore, I set up in a 3-jaw chuck, and I very carefully, very light depth of cut, just plunged in as much as I could to clean that. You'll notice I've got rather deep chuck jaws here. My 4-jaw chuck jaws are only about half that size, and I was only running it around about 110 RPM. As a result, the risk was minimised. But if you do this at 300, 500 RPM, if you've got very small chuck jaws, whatever, you might have trouble. The other ways of doing this would possibly to be put this onto a vertical mill and either use an annular cutter or a boring head to bore that out. Make up a cat's head, put a cat's head on there and use that to steady it in a fixed steady, and that would be a way to do it. But doing it this way, because all my cutting forces were basically into the chuck, I was okay. If I'd been trying to clean up the outside and plunging into it, I would have been all over the shop. So it just shows in this hobby you have to be careful, you have to think about what you're doing. So previously I've counterbored the end of my hollow bar. I've now turned a plug and I'm hoping for about a millimetre interference fit on here. I've put a centre in there. Now, some people say you can't do accurate work in a 3-jaw chuck, and that's only half right. You can't do accurate work in the 3-jaw chuck if you're repositioning things all the time, but you can if you're not going to touch it. So what I've done here is I've put the centre in, I've put the diameter that I'm going to have in my bore, plunge cutting here, on here, all in the same setting. So that and that should be concentric. I'm now going to part that off, press that into the end, and hopefully that will give me a centre in the end of that bar which I can then work from. So here I've just done a first pass. I've got my plug with centre in the end. So there are a number of ways to line up a tailstock on a lathe. The one that I was originally taught was you measure this end with a micrometer, you measure this end with a micrometer, you take them away, divide it by 2, and that's how far out your tailstock is, and then you have to adjust it. But to do that you still have to get out a dial indicator. What I discovered though, and I can't say whether I thought about this one myself or whether it was something I read, it was probably something I read, is that if you do a pass with a tool along here, this is going to be perfectly parallel to the ways. So therefore, if you then put a dial indicator on the back there, zero that, and then run that back, that will show you twice the error. And what's more, when you get there, because you can see twice the error, you then adjust your tailstock so that you get that error out. As you can see here, looks like I've got about 4 thou worth of error there, so I can just adjust my tailstock over 2 thou, run another pass, repeat the test until I'm happy with the result. So second pass, and as you can see we're almost there. One thing you do have to remember when doing this sort of thing is that if you've got a tailstock, well, as you have a tailstock, you have a lock on it. And so when you adjust the position of the tailstock, in my case it's a bolt down there and a bolt on the other side, you need to remember to release that lock and then lock it again, just so that you're not adjusting against the pull of the slides. You have to let that go, let it relax, do whatever it does, find it's nice, cozy spot, put the lock back on, and hopefully you're right. Okay, but with this, over just a bit under 300 millimeters, so 12 inches, I'm a thou out, so I'm getting pretty darn close. So we'll probably do another have a go at another adjustment and do another pass and go from there. Note too on this, this back end here of the pass, I bumped the speed up, and as you can see the surface finish is a lot better. So there are critical speeds for finishing steel, even mystery metal like this. So if you're not getting good surface finish, sometimes it pays to play with the speed a bit and just see whether you can get a better chip load. So I've spent a couple of passes trying to get rid of chatter and find a speed and a feed and all that sort of thing that works for me. I'll show you that in a minute, but as you can see here, I'm now just, what would that be, a thou, taper the other way, so I still need to play a little bit. Now as for the chatter, I was using carbide and getting lots of chatter, and didn't like that because it makes measuring difficult, so I'm using what I've been told is called a shear tool, and you may just be able to see the tip of that, but basically because of the what would you call it, the side rake on the tool, it tends to produce a chip a bit like that, and that gives you a much smoother finish, which for this sort of metal is going to be good, because I need to polish this for an air bearing, and so I want it parallel, so I don't have different diameters one end to the other, but I also need it smooth so the air is not going to hang up. So we continue. So here we are. I've finally managed to get the diameters this end and this end the same. The blue you see on there is just some texture, and I use that to show when I've actually removed material. So there's several bands plus a strip along. The size I'm going for is, I'm actually going for 1.610 because I need to polish it down to 1.609. So I think we're just about there. Once I've got the size right and I've got it polished, I then trim off a bit off this end and a bit off this end because I'm over length, set it up in a fixed steady so I can do some boring work on the ends, and that should be my shaft just about done. So here's my shaft after its final cut. Now this is an old lathe that was built back in 1957 according to the nameplate. It hasn't been well maintained, unfortunately. It's a beautiful lathe. So the bed is worn. So what I was finding was that this end was to size, this end was to size, this end was 2 thou over size. And so what you see here are, there's a mark there, there's one there, there's one there. I've actually gone and marked in thou increments the sizes. So that's to size, that's 1 thou over, that's 2 thou over, that's 1 thou over, that's to size. And then I've gone up to those marks, cranked the tool post in the amount that it's oversized to take those back down to about the nominal. You could ask, how do I know that? Well, apart from doing some measurements when this lathe first got here and discovering there was some wear in there, I did a spring pass. Now for those who don't know that term, a spring part is just basically you leave the tool where it is from the last pass, you run it across. If the material has sprung away from the tool the spring pass will, well, should, fingers crossed, take that material off. It didn't, and so from that I conclude that these areas were slightly oversized because of wear in the bed. So I've now got this down to within about a thou of where I want it. As you can see, the surface finish isn't too bad from the shear tool. I'll now cut that up and sorry, not cut that up. I'll now polish that up and then cut it. So same reason as before, I've marked off where it's high and where I want it, and I'm now applying obviously more pressure in the middle here to bring that back down to size. One thing when polishing up things in the lathe I use is this. This is a block of wood, but I've put a bit of thick felt on there. It's actually whey felt, I believe, and I can use that then to apply pressure to the work without running the risk of damaging my fingers, getting them caught up in paper. You can loop the paper around. Obviously the abrasive is on the wrong side like that, but I don't know how much pressure you can really get with that. It's good for a light polish, but I think for a heavier polish, something like my block is a better move. Nearly there. As you can see, the polish is coming up quite well. There's still a little bit of streakiness down here which I need to work on, but I should be able to get the 8 inches or so that I'm after out of this piece. When polishing with strips of emery, don't forget to use or keep your clogged up bits of emery, particularly if they've been used for polishing aluminium, because what I find is that gives you a very nice fine, almost like a polishing grit to finish off with. So the initial emery is quite aggressive. As the grains wear, it gets less so, and so effectively the grit size goes up. So you can keep some of those things. Lubricating with a little bit of something like WD-40 too, that also helps. You just got to be careful, it makes a mess, but that also helps you get a bit of a polishing action going. I've played with this a little bit more. I've got the diameter, if I measure in 25mm inch things down there, I've got the diameter within 2/10 of a thou, which I quite like, except for a little bit right down the end. I put a clock on there to measure concentricity, and I'm getting something like 5/10 total indicated runout, TIR, so that's all good. Now I'm setting this up so that I can face off the ends and do a little bit of a clean up bore. I don't want to take off much, I just want to clean the ends up where the collets are going to sit. So to do this, I'm just going to indicate along the top, and I'm going to indicate along the side, adjust my steady, and then back it off a little bit, apply some lubricant, and that should do me. One thing to note here is that I'm using what I call an elephant's foot indicator. If you ever have to indicate off along a shaft like this and you're not quite sure how well aligned that is, that's actually the better indicator to use, because the flat surface will sit along the highest spot regardless of whether the real path of the centre of the indicator is sort of up there or down there. So here's the finished product. I've put a 10-degree bevel in there, so the 5C collet goes in. It slides in quite nicely. There's around about a 2 thou clearance there, and that just gives a nice sliding fit. Part of that is because of the air bearing, which the air goes into that tapped hole there. Not sure whether I'll bother with that, or I might just put some low friction bearing material in there, some Teflon or something to try and keep that good. But there you go. You can do things on a worn lathe that may at first seem impossible. So that was a little bit longer than I was hoping to be, but I think there was some useful information and techniques there, so I'm hoping that you got something out of that, and thanks to those who've inspired me and helped me learn some of these things.